Greetings everyone. My name is Pishi Prasad and I'm from the team CodeRangers, and this is our video submission for the level Supermind hackathon. The pre-hackathon assignment given to us was to develop a basic analytics module utilizing Langflow and DataStax to analyze data from mock social media accounts. The required tools were DataStax, specifically DataStax's Astra DB database for database operations and Langflow for workflow creation and GPT integration. The task was to basically fetch engagement data, analyze post performance, and then provide insight. So, thus, working on this guideline, we created a vector flow here. And now let us look at the mock social media accounts details that we created. Thus, to create this mock social media data, we generated a CSV file consisting of 8 distinct columns, and the post ID here being the primary key of each of the data sets. Moving on, now let us look at the database that we created in Astra DB component here. Firstly, we titled this database as social media underscore DB, and under that database, we created a collection in the default key space, and that collection was titled social media details. Now, this is where the most important aspect comes in, as in this collection is where we loaded the same CSV file that I showed you earlier. Moving on, now let us take a look at the vector store RAG flow here. I've used the vector store RAG template as it's one of the most efficient ways to create a chatbot. And this flow is further divided into two subflows. The first subflow being the load data flow. As the name suggests, this is where we load the data. And after the load data component, the split text component comes into picture here. As we've basically split the text into specific sizes of chunks, and these chunk size can be user defined. Moving on, this is one of the most important aspects here. This component is known as the Astra DB tool, as I have linked my Astra DB tool to social media DB under the collection of social media details in this Astra DB tool here itself. Now, I have also used the MistralAI embedding instead of a traditional OpenAI embedding. I will come on to the embeddings in some time. Here, the most important part, I think, is the parse data component here, as it converts the data into specified templates. Now, let us look at the data retrieval flow here. Firstly, we've used the chat input component, as we have to talk with the chatbot. We have to provide user input. Thus, chat input is is the preferable input here. Moving on, again, we've used the same Astra DB component here, linked it to the same social media database and the social media details collection. We've parsed the data so that it becomes readable. Now, we've provided a prompt wherein we've asked the chatbot to be a social media engagement analyst, and we've used two dynamic variables, context and question. The question is directly linked to the chat input, and the context is linked to the past data. Moving on, this is another important aspect of our flow, as we've used the Groq AI model here. We've generated the API key of Groq and also of MistralAI and linked it to the vector flow model here. Last but not the least, the very last component of this flow is the chat output, which basically, as the name suggests, is the chatbot trying to communicate with the user. Now, let us try to implement it. Here we can go to our playground or basically chat with our chatbot. We can create a new chat and let's ask any insights on social media. For example, which post type has the highest engagement? Now, it will read the data that we have provided to the database, and on the basis of the data that we have provided, it will give additional insight. It will give an answer based on this. As we can see, Reels is the highest engaging post type. Furthermore, it will also provide additional insight and actionable recommendations. We can ask another question. For example, what user has the highest engagement? From the provided data, we can see that user 7 has the highest engagement, and it has basically done some calculations to come to that conclusion. Furthermore, it has also provided additional insights and actionable recommendations. Now, after that, we've made the RAG flow and linked it to the database. We decided to give it a front end. And to make that front end, we use a Python library known as Streamlit. Now, when I run Streamlit on localhost, it will take me to this front end. And after that, we also deployed it on Streamlit.cloud so that it's available to everyone. If we take a look at this, this is our social media insights analyzer chatbot. We linked it to our GitHub repo, and from this repository, we could deploy it on Streamlit. Now, if I ask this chatbot, which post type is the best, by the data that we have provided in the CSV, it will give us the post type engagement matrix and a few additional insights and actionable recommendations. So overall, this is our final submission for the hackathon. Thank you.